good afternoon and good day, people from across the globe who are attending this meeting. This is Professor Sai Baba. It's my privilege to be the anchor of this session, day 3 and session 2 of the day 3. And it's a technical session 4. And the theme is research data management. And we have a Dr. Cinzia Daraio, the keynote speaker. And we have 3 panelists and 3 discussants. I will come to them at later when the turn comes. Well, I think to just get the context, I'll just say a few words to new dimensions are being added to the way research is being carried out. So sharing research data is not only of paramount importance, but it has become imperative. It would enable reuse of research data, perform comparative analysis, and also can lead to designing different application of the data the researcher who generated have not thought of. Maximize the outcome of the research and reduce the cost of carrying out, generating the data. Cloud sourcing, collaboration are becoming things of the present. I'm sure all of you recall Shanmuga Subramaniam. He was the first person to identify the debris of Vikram, the ISRO's moon lander. And he used the lunar surface with the dots, with all the data that is made available. And what is interesting is that Shanmuga Sundaram is a mechanical engineer from Chennai. And this discovery has come out of his hobby. But I think more importantly, in the context of today's meeting, what enabled this process is the availability of the data and free access to the same. I think that's what made things happen. So research data management involves organization, storage, preservation, and sharing. And it is time to create reliable infrastructure and adequate data management process for robust institutional policies for this sharing. And naturally, research data management has attracted interest of researchers from diverse groups, data scientists, researchers, library and information scientists, and you would find many of them attending this meeting. So there are 2 aspects to data management. One is the digital infrastructure to host large amount of data and the infrastructure to make it easier and affordable to access. I think when you generate the data, enabling sharing and making it easy to the researcher to do so, and as the expertise of the research is not in sharing or making the data available. In fact, research data management is a very good example of expertise of different domains coming together. The effort is to make it congruent, be it doing research or make it available for sharing. So the session is focused on outlining and delineating the gamut of issues of research data management, policies and principles, best practices, processes and technologies, metadata, copyright, and so on. Very happy to have Professor Cinzia Daraio. She's a professor from Department of Computer and Control Management and Engineering at Sapienza University of Rome, Italy. And she's a full professor there of the Management Engineering in the DIAG department of the university. And she seemed to be loving teaching. She teaches productivity and efficiency analysis to Masters of Management Engineering people, quantitative models for economic analysis and management for Masters of Data Science students, economics and business organizations for different engineering and undergraduate courses, and economics for Masters in Electrical Engineering. So it seems to be very diverse teaching interest. And we are happy to have Dr. Cinzia. I extend a welcome you to deliver this keynote address. And it is for about 40 minutes. So what I would do is around 5 minutes before for the 40 minutes, either I will raise my hand. If you're not noticing it, I may indicate to you that 5 minutes are there for you to close. So welcome again, Dr. Cinzia. The virtual platform is yours, and please deliver your keynote address.
Thank you. Thank you very much, Professor Baba. First of all, let me say that it is a great pleasure for me to be here, and I would like to thank the organizers, in particular Professor Shalini Yurs, that is the program chair of this conference, for the invitation. I'm going to share with you my views because I think, as the chair said, it is really an important topic. And let me share my screen so that I can show you some thoughts and also some results of some projects that we carried out within my university on research data management and infrastructure. You can see the title is basically research data management is the title of the session. I'm going to show you the outline of my presentation. I will start by some recent trends in research assessment, introducing the main topic, the assessment. We are assessed everywhere, computerization of bibliometrics, that have been very frequently, altmetrics measurement, and also these factors have contributed to the complexity of research assessment. But on the other hand, there is also an increasing demanding policy needs in terms of indicators, granularity of the indicators, of the production of data and indicators coming out from data. And in this process, we see that there is a crucial role of the data and challenges in data integration that were exactly the main issue addressed by our chair. I will show you that we need also to have a broader framework to handle all these factors that are happening together. And I will give you some views on the experience we had with the Sapienza, which is the Latin words for wisdom. And it's also the Latin words of our university, Sapienza. That is the ontology of multidimensional research assessment that we developed within our university to try to answer or to try to propose also recently introduced data management techniques for addressing the topic of research assessment and integration of heterogeneous research data. I will show you also some features of this technology that I think could be powerful, but as everything, there are some costs. And we should be also aware of what are the costs of this kind of infrastructure, what are the possibilities, and we have to come back to what are data to understand this and the challenges of data integration. And then I will show you some research in progress that we have coming out from this research. Just to start, some challenges for data integration that are indeed the grand challenges we identified in a paper with Glanzel in Centometrics 2016 are handling big data, coping with quality issues, and also try to anticipate new policy needs. Because when you build a data infrastructure, you should take into account what will be the purposes and the uses of these infrastructures also for the future. And so you have to try to anticipate new policy needs. And of course, big data, we will see, means a lot of opportunities, but also bigger problems. And we have to take these into account. And these challenges were framed taking into account some areas of intervention that are: how do you collect data, what kind of project initiatives you put in place, and also the topic of open data is strategic. You should, first of all, have data, so the availability of data, but then the data should be understandable and should be integrable. And so also linked data and platforms for integration of data, technologies for integration of data is really crucial. But then we have also the problem of monitoring the performance, the evaluation, what we are doing, why we are collecting this data, what are the purposes. We should have a kind of strategy or vision of how we want to use the data. Because if we build an infrastructure, this has to be reused. As I will show you also some definition of infrastructure, data as infrastructure, that I think can be helpful in understanding this. And when we think about monitoring the performance, the evaluation, the purposes for which we collect data, we come to the problem of stakeholders. Who are the stakeholders of our data infrastructure? What are the actions that we have to put in place? The different options that we have, of course, and also the cost and the sustainability of what we are doing. Because as I will show you, the project we developed and the technology of data integration that we proposed is an infrastructure, but it requires some costs and it has to be maintained. So it should be an investment that should be done in a serious way. That means investing the money for building the infrastructure and for maintaining the infrastructure. And so we come to the sustainability. Can we sustain this? Should we sustain this? These are all questions that have to be taken into account in our understanding. And then we identified also several critical issues. Of course, the first is data quality. The main requirement is the data availability. Without data, we cannot build an infrastructure. But then the quality of the data is important. But also here, we don't have a kind of objective quality of data. We know that quality should be considered as fitness for use with respect to the user needs, what we need to how we need to use this data. And we have the issues of completeness, validity, accuracy, consistency, timeliness. These are all dimensions that should be taken into account. And we know that for some purposes, a given level of quality could be acceptable. For other purposes, it is not. So it is important to take into account what are the purposes of our data infrastructure, of our infrastructure when we think about this. And then we have the comparability problems, because now we are in the big data era, but we have a lot of data that are heterogeneous. We have different definitions, and even if we have the same units in different databases, it is sometimes difficult to put the data together because we have different heterogeneous and not compatible definitions, standardization procedures, or different data collection practice. And this is something we should take into account. Standardization is one problem. Lack of interoperability is another problem. And another issue that can be really important is the lack of modularization, because we know from an engineering point of view, if we can reduce in modules a bigger infrastructure, we can handle the different systems, subsystems in a more efficient way. We have also problems of classifications. There are different classifications for the different kind of data that we have. Difficulties in building concordance tables to put together different databases that have different classification schemes. And so, again, to really exploit the powerful of opening data and sharing data, that is really a must. I really completely agree with the chair, Professor Baba. It's a must. We cannot avoid this. We should keep these challenges into account to do a work well done. And this means also think about the cost of extensibility of the system. If we build an infrastructure, we should take into account that it should be extendable. When we have new knowledge, we have to be able to introduce this new knowledge in the system. And we have to think also to the costs and the updating of the system. I'm going to come back to the more technical details when I will show you the research data management problem infrastructure that we built at our university. Just an introduction about data. It is really important, but data have a problematic definition. Of course, we are all aware that data are not just a second order artifacts. They are really the heart of what we are able to show, of our evidence, of also of the theories that we are able to build, are a relevant dimension that is often neglected, but it is also, data have a problematic definition because it depends on the use, not on inherent characteristics of the data. We can think about data are objective, but as it was illustrated in a very nice book by Christine Borgman of 2015, data have a problematic definition. And I'm going to show some more information about the data, what are data, coming back to the book of Borgman, after having just introduced the powerful of data, why really data are important. I'm just citing this document by the OECD on data-driven innovation for growth and well-being. I will go very quickly on the slides. They are quite dense, but the idea is that data are really great, are really an important resource that can lead to new knowledge, to drive value creation, foster new products, processes, markets. This is really what we could achieve, data-driven innovation. So, and here for this, we should keep into account that we need high skills in data analysis and statistics, but also expert domain-specific competencies. And these challenges is really connected to the democratization of data analytics that can be helpful in this process. I'm just showing the industries where this data-driven innovation happens, internet firms, other of the ICT sector, but not only. There are several studies that suggest a positive impact on the use of data and analytics of 5 to 10% on the productivity growth. So this is really something we should keep into account. And we also take, it's a kind of, we see that we are going further to the servicification of the entire economy, including also low tech industries. And also most of data intensive sectors are outside the ICT sectors, include the financial sector. This is something that we know. That is why it's important to invest in data, in the opening of data, in the sharing of data. And all the industries that take advantages, I'm just citing in these slides, healthcare, research, education, public administration. There are opportunities in basically almost all the sectors to benefit from these advantages. But we have to take into account the challenges that we have to keep in mind. I'm just quickly considering the three main categories to be able to allow that the opportunities of data-driven growth are able to preserve and improve social cohesion. And the three main categories are supply side challenges, demand side challenges, and societal challenges. About the supply side challenges, they are related to the provision of data and analytics, those that offer the data and the analytics. Demand side challenges relate to the capacity of exploiting the data, the data-driven innovation. And then societal challenges are affecting by both sides, and think about the long-term impacts that we can have on the democratic market economies, on the well-being of citizens. What is the impact of this on the societal well-being? Here, very quickly, I'm not going into all the details, but just to say, supply side challenges, we have to have data access, ownership, and incentive issues. People should have incentive to provide the data. Demand side, you need skills and competence, organizational change within the organization that have to use the data and the technologies, entrepreneurship. You have to foster the entrepreneurship to allow that really we have an exploitation of these technologies. And societal challenges, loss of autonomy and freedom, market concentration. we have to take into account that we can also increase inequality. We should keep this into account. Structural change in the labor markets and limitation of the traditional security approach. Because of course we have to go toward clouds, toward extension, but what are the limitations of the security on this policy? We have to take this into account. I think this is important because once we keep these challenges into account, we can come back to the data that are our main ingredients we have seen are not pure or natural objects. They are not objective. When we were child at school, we were saying that data are uh, mathematics is not an opinion, data are objective, but now we can think that data are not pure or natural objects with an essence in their own, are not objective at all. They exist in a context, taking on meaning from that context and from the perspective of the beholder. So if we want to share data, we have to keep this into account. And the degree to which those contexts and meanings can be represented influences, of course, the transferability of data. This is really something we have to think about in our understanding of the problem. Data are then representations of the observations or the objects or the entities that are used as evidence of phenomena for the purposes of research or scholarship. And so they have their existence because they have also a concrete bounded definitions in their operational context. This is really important because we have different categorical definitions of data according to the origins. Just taking this classification of data, we can distinguish between observational data, computational data, experimental data. These are different kind of data. And of course, the different meanings can have an influence on the use and the reuse that we can do of this data. We have also other categorical definition collections. Research data collections are those that result from one or more research projects. These data add a minimal processing or curation and may not conform to community standards for format and structure. Again, if we want to reuse data, we should keep this kind of distinction into account. We have, on the other hand, resource or community data collections that are based on, maintained by the research community and serve as a continuing need and may establish standards in the community where they are produced. And we have also research reference data collection that serve large communities and are more connected to robust standards that are connected to the community beyond these kind of collections. So we have different categorical definitions, and it is important that these kind of conceptual distinctions applied more and are more crucial for social science and humanities, because all the different categories that we have seen can be considered arbitrary because are the results of decisions about criteria naming. You can have, for instance, raw data, and depends on where the inquiry begins. For social science to collect survey raw data, maybe the forms filled in the interviews. So in humanities, the meaning of data is particularly ambiguous because you have different sources, primary sources, secondary sources, tertiary sources, and according to the kind of sources, the raw and processed data distinctions are really important factors to consider. If we really want to exploit data, we should keep carefully into account their specificities. But then, if we are well aware of what data are and their challenges, we can think about data as infrastructure. And this is another nice book by Frischman that really suggests what are the three main criteria to consider data as infrastructural resources in the book, The Social Value of Shared Resources. And the three main criteria are just reported in the next slides. Data are non-rivalrous goods. This means that can be consumed in principle an unlimited number of times. And this is important to have spillovers to maximize the access, because if I use the data, I'm not consuming the data. The data can be shared. This is an important feature of data as infrastructure. Then data are capital goods. So this means that are not a consumption good or an intermediate goods. In most cases, we know that having a capital goods, goods that are not material inputs as fuel, but can be used and reused many times. And this is another important feature of data as infrastructure. And the third feature is data are general purpose inputs. This means that infrastructure resources enable many systems to function and satisfy demand derived from many different types of users. And this is, again, another important aspect for the data sharing and reuse of data, data considered as infrastructure. And this is particularly useful for public sector data and administration, because the data sharing and reuse can be really helpful for the society and the societal to meet the societal challenges and to reduce inequality instead of increase inequalities. Of course, the step further is open data. Once we have understood the critical challenges, we have considered the powerful of having data as infrastructure, and then we can go to the opening of the data. That means basically the data can be used by anyone without technical or legal restrictions. And this means access and reuse, exactly as it was recalled at the beginning of this section by the chair. I just want to go very quickly to the three main aspects of the open science that I think are really important, because from open data we go to open science, and we have open access, open research data, and open collaboration. This is the third ingredient that I think it is really important, and it is also enabled through ICTs technologies, as we have seen with the platforms and infrastructures that are really important. Part of the architecture of an open science system is also the technologies for the ICT infrastructure. Now, in this, to go further and to go on the usage of data in a system, in a data integrating system, we need really an overall framework to understand how to design our knowledge infrastructure, what are the purposes, what are the monitoring, what we would like to achieve, because this is really important. And here you see three main dimensions that were identified in this framework that I think are able to capture all the main elements. Just let's see together. I know the framework is quite dense. I'm just going to give you a flavor, and then if you are curious to go in deep, there is a paper that is cited in the references at the end, so you can go further. But basically, data are just a dimension in our framework, together with the method and the theory. Because why we need a framework? We need a framework because we need to develop models and to check if the models that we have developed are robust or not. We have to know what are the main dimensions and what we intend to do. In this framework, we have data, and you see the three main features of data are availability, interoperability, and so-called unit-free. I'm coming back to these features later, but just to tell that this data, the data components, is really important and contributes together to the other building blocks of theory and method to our understanding of what we are planning. And we see that quality which is fitness for purpose, keep together the different dimensions. I'm going just to go further on the building block of the interoperability of the data, connecting the quality of data with the context-dependent feature I was citing in the previous slides, coming back to the book by Borgman. In fact, we see that the linkages between different data sets are relevant, but to link together different databases, we need the compatibility, the interchangeability, and the connectability. And here you see that the data integration, it's really a serious problem in the big data era, because we can have different level of interoperability. We said that the first main requirement is the data availability, but then we need also the interoperability, data that should be interoperable, interchangeable with the other sources. And here we can have different level. The lowest level is that it is not possible to integrate the data. So you have different databases, but they are not able to speak each other. Then you have the an intermediary level, that is the system does not guarantee consistency across database boundaries. And so it is quite, I would say, difficult to put together different databases that are not really coherent among them. Then you have the higher level of interoperability, which has the goal of developing a global system on top of the existing system to provide the desired level of integration of the data sources. And this is what we try to achieve with our experience of the Sapienza ontology. I'm going to show you later. And it is clear that if you have to build an infrastructure, a data infrastructure that should last for some years, you should think about what is the level of interoperability you wish. Because if you want to build really an infrastructure, a data infrastructure that should last for years, you should think about the level of harmonization, and you should go from the documented data, that means just having the documents of heterogeneous database that are not able to speak each other. You can have aligned dynamical data that just try to have some common system approach, or some opening of the code just to understand better the data. Then you have a kind of harmonized data and processes in which you try to have a common conceptual model with a kind of semantic consistency. And this is exactly what a kind of ontology-based data management approach could allow us to achieve. You see here the different approaches to data integration. Here there is the so-called procedural on the left of these slides. You see the so-called procedural or bottom-up approach, that is basically the so-called silos approach, in which you have the different databases that are heterogeneous, and for every indicator or for every usage of the data you need, you have to access and design the corresponding service. On the other hand, you have a kind of declarative or top-down integration, in which you build a system, define a global structure, which is valid for all the source of data. And then you link this structure to the data, so that when you have to specify the indicators, you use just what you have, the global structure, instead of having to specify on each database what is your question. And this is basically what an ontology-based data management approach realizes, because in an ontology-based data management structure, it's a kind of new declarative paradigm when you use the knowledge representation and reasoning principles and techniques for managing the data. Here, just a second. Yes. Here you see that you are able to leave the data where they are. Each database lives where it is. You can build a conceptual specification of the domain, discussing on what are the main variables of your interest, you express all the indicators over the abstract representation that you have done of your knowledge domain, and you automatically translate conceptual indicators to the data. Of course, this is I think really a powerful tool for data integration, because basically you have your real world, and here you have a kind of representation, a kind of three-level architecture in which you have the ontology, that is basically the conceptual description of your domain of interest. And then you have the data world that is basically built by the sources of data on which you are interested, that can be mapped to the conceptual specification of the domain you have done on the ontology. And then you have the mappings between the concepts and the data. This is the structure of an ontology-based data management system, and it's a form of information integration in which you use the global schema, which is a kind of global representation, the conceptual model of your domain, which is specified as an ontology expressed in logic-based language.
Yeah, see, after this
yes.
keynote speaker, we are not allowing any question answers. No, Q&A will be at the end, right? Or
so you see here, we have the three main sources: the ontology, the sources, the mapping. And if you are able to have specify the conceptual, the formal description of the domain of interest, then the sources are the database that can be heterogeneous. And then the mapping is really the specification of the correspondence between the data contained in the data sources and the elements of the ontology. Basically, in our experience with Sapienza, the ontology of multidimensional research assessment, we aim at defining the ontology in which we should be able to try to investigate the efficiency, the effectiveness and impact of education, research and innovation by looking at direct and indirect measures of performance. And here I'm going to specify the main advantages of this ontology-based data management approach that was implemented through the ontology, to our ontology. Basically, users can access the data by using the elements of the ontology. So it is easier for also the policymaker to access the data, because they have just the concept related to the data. By making the representation of the domain explicit, of course, you can improve the reusability of the acquired knowledge, and this is quite important. And also the mapping layer give the opportunities to provide the documentation and standardization of the different procedures. And a fourth element of advantage is the flexibility of the system, because you do not have to merge or integrate all the data sources at once, but you can progressively add new sources when they come, or if they are costly, when you are able to afford the different sources to be integrated. Then the system is extensible. This means that if you have a system, you can increase as soon as you also do developments in the domain. You can add modules, you can also extend the ontology, and then you can open the system, because basically you have a conceptual framework in which you describe what are the main concept definitions, and then you can use a common language for the community. This is really important, because you use the ontology and the concept of the ontology as a shared dictionary for the community, and is really a step towards an open science system. This is a picture taken from a paper we published on Cytometrics that is in the references, which describe the main advantages of the ontology-based data management approach, in which basically you have the main conceptual representation of your domain. You have query on the ontology, and then you are able, through the technology. The technology is the Mastro system that is also openly available, that has been developed by some engineering and computer science colleagues from my department, that are able to connect the concept to the different databases. And each database is, of course, connected to the different documentation. You can really have an open system, and you can share, and you can also test the quality at the source level and at the conceptual level. This is quite really an important aspect. Just coming back to Sapienza, I think I have to go a little bit faster. We 5 minutes, so I have to go faster. We developed the Sapienza. You have all the details in the slides and also in the references. This was the first representation of Sapienza with the different modules. Then we enriched the different modules, reaching to the 3.1 version with 620 concepts and relations, organized in 12 modules with the time, and then which is a kind of over module, taxonomy, space, and representations. I'm going faster just to say that in describing all the different modules, we learned more about indicators. We were the opportunity to think about, if you have to describe all the concepts and the relationship of the domain, you can think further to the different aspects, and also the representation, having the possibility to propose different representations. If you use one data source or if you use another data sources, this provided very helpful. In this, of course, what is the price to pay? You should do the mapping to this infrastructure of the different data sources to the ontology, and you should keep the ontology, you should update the ontology. If you have developments in the theoretical framework or in the theoretical literature, you should include and extend your ontology, your models. You should add, maintain the infrastructure. It is an investment. It requires some costs, but then could be helpful because you do the effort to start with an infrastructure, but then if you maintain and you extend, this could be really a powerful infrastructure to contribute to the innovation and the development, as we have seen at the beginning of the presentation. What we are doing now, basically, we are combining the ontology-based data management structure with the visual analytics to understand performance models, how they are robust, to connect basically our understanding with a robustness analysis also of the models that we are able to reach. And we think that visual analytics is really another powerful field of investigation that is a kind of natural extension, because we have seen that thanks to the visual analytics tool or environment, we can really let people and user interact, because you have the opportunity to enter not only into the data, but also into the modeling. And I'm just closing. This is just what we discussed in a recent papers, in which we put the, I'm just going to show here. Basically, you have the user is really able to enter into the visualization of data, derive from the data the models, check the robustness of the knowledge, and come back. And this is really a powerful integration of the ontology-based data management and data access that we developed before with the visual analytics environment. And I'm closing. Basically, we were able to put together two important aspects that were described in the last edition of the Springer Handbook of Science and Technology Indicators, one on the challenges, approaches, and solutions in data integration, and another for the measurement of the research productivity going beyond the traditional approaches in this field. And I have almost finished. Just in this last slide, you find some of the selected references, basically all the work that we have done at our university to address this. That is really, I think, a crucial topic data and research data management for really exploiting the powerful of open data and the new developments in the technical infrastructure. And now I'm to the final slides, just to thank you very much for your attention. Any comments and questions are really very welcome. So thank you very much. You find my contact also here. I hope I keep the timing.
Yeah. Excellent, Professor Cinzia. You was just about to 5 seconds ahead of 40 minutes. I thank you for sticking to the time. I think you raised very important questions. I think you raised about data quality and the social cohesion, I think, which you mentioned about how important it is. And I think you also discussed about ontology-based data management. I'm sure that you set the platform for further discussions. I thank you. Now we will move to the panelists, and then you would become part of the discussions as the panelists would start. Thank you once again for excellent talk.
Thank you very much.
Also for sticking to the time, making my job easier.
Oh, thank you. Thank you very much.
Yes. So, okay, now, we have 3 panelists identified, and each of the panelists would probably talk for about 10 minutes, and then that would lead to further discussions. So it will be the first on the list of the panelists is Dr. Brembs. He's a professor of Neurogenetics at the Institute of Zoology, University of Regensburg, Germany. I think he has a PhD from University of Würzburg, postdoc at the Houston Health Center, and spent some time as a researcher at the Free University Berlin, and currently is the professor of neurogenetics at the Institute of Zoology at the University of Regensburg from 2012 onwards. He also served as the adjunct professor at Department of Genetics and University of Leipzig. So I have I invite now the first panelist, Professor Brembs, to address.
Great. Thank you very much for the invitation and for the kind introduction. I'm in the process of posting actually 3 different links. 2 I already have posted. The third one is going to go in so that into the chat box, so that these are examples for a project I'll be presenting in a few moments. So now you have all 3 links in there. Yeah, they end with 440, 441, and 442. And I'll explain what these links mean and how you can explore all the raw data that we've published there automatically. So let me share my screen with you. One of the main issues for us as working researchers is that data management plans and data management itself usually is additional work for which we usually don't have time. And many people, especially starting, don't have a lot of inclination to do it, because the important thing are the experiments and the results. And then handling the data afterwards is really not something that people get very enthusiastic about. And so how you can conceptualize the problem in our case of research, where we work with flies and we do behavioral experiments with single animals mostly, is that you design an experiment, you produce data and metadata. The data go through a quality control pipeline that you throw out stuff that doesn't meet the quality control criteria. And from those data and metadata, you then produce graphs and statistics that prove or falsify your hypothesis. And many of those graphs and stats then go into a publication. And then once you've done all that and you've told the world what you've discovered, then all of a sudden it's like, oh, wait a minute, now I have to put all of these things, all of the data and the code and all of this in some database that people can check it. And that's the part that people are not very enthusiastic about. And that's the part where ideally it should be so automated that this wouldn't be an additional piece of work. It's just something that the infrastructure would take care of. And so one of the projects that we've done a couple of years back is to automatically deposit the raw data and the evaluations. And in this case, we used Figshare to do that. So what we did is we wrote, so we usually use R to evaluate our data. And so we write scripts that take the metadata, take the data, and then generate these graphs and stats. And in this case, our scripts automatically contact the database from Figshare and deposit all the raw data together with the metadata and the evaluations in an open database from which we then can generate a publication, but of course, which also are searchable and findable, are fair on the Figshare database. And the way this works is essentially you just add a few lines of code to your R code to say that you this is you, or in this case our lab account. You have certain tokens here that tell Figshare who you are and what project you're working on. You can add some additional information and metadata to this, but much of it is already included in the metadata that we provide, and then these things get automated. That's something that we've done a couple of years back. We're still doing this to some extent, but this is still sort of complicated because it requires the students to understand the evaluation scripts very well. And many students in biology, they just come and use the scripts that we've provided for them. And so this is not perfect. While this works for graduate students and postdocs and me, but for other people, this is not very convenient. So we've tried to do a different, to improve on that approach with a modern project that's a little bit similar to the ontology-based approach, only not as sophisticated. So here we link together the lab journal, the data models that explain what's in the raw data, and the publications. We want to link them together using HTML and other markup languages. And because everything is based on markup languages, it would be easy to add ontology-based technology to this. So one of the projects, we organize our experiments into projects. And so each individual fly experiment is a time series experiment that's recorded in one XML data file, and all of those XML data files constitute the raw data of, let's say, very often 2 or 3 or more experimental groups. The grouping of those files into each experimental group and the experimental design is written down in a YAML format. So YAML ain't a markup language, a YAML markup language document, one single document per project that also simultaneously serves as a lab journal. That's why we picked YAML, because it's easily readable and writable, even though it's a markup language for human readers and writers. From the XML data file, our scripts, and those scripts are also linked in the raw data. So the data model is linked there, the software for the data analysis is linked there, and the software that collected these data is also linked in these raw data files, XML files. We generate quality control HTML files that then instruct us which of those raw data here meet the quality criteria, and all of those that do meet the quality criteria then are used to generate the evaluation, from which we generate, again, figures that go into publications. And the goal here is to find, this is something that's close to completion. We're looking for a publisher now where we could have these hosted HTML files where we can drag and drop them in a manuscript such that the published manuscript would link back to this HTML document, which would then link to all of these components of the project via those other different files. So essentially, one drag and drop of a single evaluation into the manuscript would allow the reader to access everything from the lab journal to the raw data, all the metadata, everything. So this, we're in close completion, and those 3 links that I posted in the chat box, they link to this HTML evaluation sheet. And so you can see that you can click yourself from this HTML evaluation sheet to the quality control HTML sheets, to the XML sheets, and you should also be able to get the YAML file from where everything is organized. And those are 3 projects of a graduate student of ours who's just recently uploaded all of his data. And we automate this by having a Python script running upon login that checks whether the currently used or currently worked on project YAML file, whether that folder where this YAML file resides has any changes to the folder that's on the published or publication server of the university. And if it is, it synchronizes the two. So it's an automatic backup and it's an automatic publication system. And if we add a tag to the YAML file that the project is complete, the publication server will assign a DOI. And so via that publication server, you can reuse the data, you can access the software, you can access the raw data, everything is automated. And that's how this is the server that I provided the links to. This is how you can access these raw data as well. And so the final project was about showing how these kinds of open data and open science can open up new avenues to interact, analyze, and interpret scientific results. Because once those data and code are published, you might not even have to generate static figures anymore, because what you can do, and we spearheaded this development a couple of years back, 3, 4, 5 years back with F1000 research. So you can go to this article, for instance, and if you're interested, if you don't find it, it's easy to find via the title, but if you don't find it, I can also post the link to it into the chat box. But there's also a very short URL here that you can use. If you go to the figure 3 in this publication, what you see is that it says loading, please wait, because what we've done here, we've given access to the code, we've given access to the data to the publisher and said, here, look, use the code to generate the figure. And so you go there, it loads the code, generates the figure. And if you want a different kind of display for the figure, so you want to interact with the science here, you can choose, for instance, this is just a proof of concept, you can choose here a different way of displaying the figures with the 10th and 9th percentile, 10th to 90th percentile, and you get a different display of the data. So this is what you can do when the data is available and you don't just have, ready-made pixel graphs. And finally, the last slide, what you can do as well is you can open up the data. This is figure 4 in this publication. And you can add, if you have done your same experiment and you want to see how your results compare to ours, and 3 labs have done that in this experiment. You can see here, this is a principal components analysis. It doesn't really matter what the data are and the visualizations. The green parts, the green symbols here symbolize our data. And those are data from 3 other labs that have done the same experiments with the same type of flies. And so you can have a collaborative project that starts with a publication and where you don't really need a lot of coordination. You can just submit the results and they will be incorporated into the figure. And with that, I will conclude my short presentation of the 3 projects that we have used. Thank you very much.
Thank you. Yeah, the next panelist is Dr. Aastha Madaan, and she's a senior data scientist at Arup, London. And with more than a decade of experience in application of AI, ML, IoT in academia, industry, and the built environment. She did her PhD in computer science from University of Aizu, Japan. And she was at Bangalore at IIIT doing her postdoc, and then moved to University of Southampton when she was given a Newton Award, and then joined the Southampton as a research fellow. And she received Staff Achievement Award for her contribution to research on IoT data sharing infrastructure and Web Observatory. I think she's a well-published researcher, delivered talks in several conferences. So here go. Welcome, Dr. Aastha. 10 minutes. After 8 minutes, I raise my hand and then we can do it. Okay.
Perfect. Thank you very much for the kind introduction, and hello everyone. So in this talk, I'm going to reflect on the work that I did as a postdoc both at Southampton Uni as well as IIIT Bangalore. And I think I was lucky to be in the right place and in a community of professors and the research community who already thought that sharing the data is of prime importance, and not just the data sharing, but also the methods that we are developing over these data sets and the research we are doing in different parts of the globe. So I would talk about the Web Observatory, and we call it the Web Observatory because we talk about sharing data sets which were related to the different research that was related to, say, the emotional contagion about the celebrityness on the different social platforms. But the underlying principles and the learnings that we learned from this platform was applicable to IoT, it was applicable to the businesses in the current format and everything. So let me just give you a glimpse of the final system that we built. So here you should see a quick introduction of how you search a data set. You can search the apps on the observatory. You look at the access on the observatory. So let me just go back slightly, and then I will talk you through about the technical things. So here, if you see that it's an open, it's accessible by everyone. There is metadata, there are comments, and you keep going, you have different applications. So this one is about looking at the haze in Southeast Asia, an application developed by one of our PhD researchers at Southampton Uni. And then you see all the graphs and everything related, which is built on top of the data, and it links to the GitHub of that person to see how it works. And then you can search for different data sets if I want to go. So that's the kind of the front end of the application. But let me just reflect on the principles. So the whole idea behind this Web Observatory and the network of Web Observatory was to bring together the community to build a socio-technical system of the researchers who were working on different aspects of web science. And the whole idea, the concepts of that we embrace on open data sharing, closed, there are some data that cannot be shared openly, or there is data, already the open data initiators were carrying out with different governments, publishing the data, but then there are data sets which might have sensitive data, whether it is the Twitter feeds, whether it is any kind of spatiotemporal data from the IoT data sets. All those different impacts were there. Then we talked about the transparency. You would like to see the provenance of the data, and how do you reflect on those aspects of which are conceptually very understood, but then how do you implement on this system? So the whole idea of the Web Observatory was to build this distributed digital or data infrastructure, and which embraces the concept that if I am a researcher sitting in London and there is another research community sitting in Bangalore, we can still have the ownership of our data, but then we share just maybe the metadata, or we just on this Web Observatory, we just link our data set. So you have the ownership. I have the data profiling, whether it is the data quality, or whether I talk about the provenance of where did I get this data, what is the data source, or I want to map any kind of data that is associated. I can, it's basically a way of making the data accessible. And through this whole network of the observatories, just to give you a glance, it was not just the one observatory that we had at the end of the day, but all that you see here, the different data sets that are visible here, come from a network of observatories. So we had an observatory at the Web Science Lab in IIIT Bangalore. We had another observatory in the Northwestern University. We had one in the Adelaide University, one at the Southampton Uni, then different nodes in different parts of the universities in the UK. And they all had their ownership, but what we were allowing people was to come together and share their methods and share their data sets with each other, and to just create the socio-technical ecosystem of sharing the research data. We navigated through all the challenges that you face, that people do not update the data, and at some point it becomes redundant. So keeping tap on that, making sure that everyone is aware of when the data was last published or updated, or whether it was about the metadata, that a relevant metadata is complete and is available for people to see. Where is the link coming from? So you see a lot of undefined link to the source here, which is, I think, the best example of what are the challenges in sharing the data in such a kind of an ecosystem. But on the other hand, if I reflect on the positives with this whole idea, the principles I talk about, like the data trust I mentioned, or the transparency of data sharing, we could take these principles and we could build something which was very tangible, which was a UK-wide IoT data sharing testbed, which brought all the IoT companies, the SMEs, as well as the research communities in the IoT area. And we built something called as the IoT Observatory, which was like a sister observatory, but then you have all the sensory data, which was available for research purposes, for any kind of prototyping in academic industrial collaboration. And then also this whole idea, if you reflect on this, when you are sharing all these data sets about from different countries, from different geopolitical scenarios that we have, it's a very good source of where you can reflect, you can understand how people believe in the web, how people are using the web, how different communities come together, what are the different geopolitical and social scenarios that build in different parts of the world. And when you go and design policies on data sovereignty, on data sharing, becomes a very, very important aspect. So when we talk about internet governance, it's not, with the way the world is changing, with the way we are digitalizing ourselves, the policy making is not just on the infrastructure level, but it also is influenced by all these factors. So the whole idea of sharing the data can definitely input, not address all of the policy making challenges, but also gives a lot of data evidences for policy making. So just this whole platform that we built about the Web Observatory was fantastic in terms of influencing the policy making, influencing the government's AI review on saying why data trust is important, why having an open Prof standard that we have on W3C is important to implement in the metadata. Why is it important to know who is the owner of the data? We talk about the downstream analytics. We talk about the nice machine learning applications we want to build, but the whole, if you reflect to the other spectrum, the sharing of the data, the trust that we build in this data, and the communities that we build around research data management and sharing is even more critical to make us successful for the future, and even more so in times that we are all on the digital platforms and on the data platforms. I think this is the best reflection of why data sharing and is very, very important in today's times. So I will save the 2 minutes there, Dr. Sai Baba.
Yeah, very nice of you. Thank you.
Thank you.
Yeah, I think you really saved. I think I was about to raise my hand. Thank you for. I understand now what you mean by your expertise in, you said built environment. I think you're referring to this.
Yes.
So thank you for that. Now we'll move to the third panelist, Dr. Makx Dekkers. And he's an independent information professional, member, Research Data Alliance of Europe. His extensive experience in information technology, standardization, and international cooperation spanning 3 decades. He was the editor of the FAIR data maturity model, creating consensus among global community, and previously worked in several key management positions at PICA, Center for Library Automation in Netherlands, and at PricewaterhouseCoopers in Netherlands again, and also as a managing director of the Dublin Core Metadata Initiatives. So may I invite now Makx Dekkers.
Thank you very much. Okay, so thank you very much for introducing me, Dr. Sai Baba, and also thank you for inviting me on this panel. What I wanted to do just briefly is report on some work that I've done for the Research Data Alliance on the FAIR principles. Now, I'm quite aware that you probably know a lot about the FAIR principles already, but in case you haven't heard about the details of those, I just wanted to briefly introduce the FAIR principles, saying that the FAIR stands for findable, accessible, interoperable, and reusable, where you can see that many of the things that came in the presentations from Professor Daraio and also the other panelists reflect on some of the words and some of the concepts that are in the FAIR principles. On the findable part, I always think that mostly on the level of identifying the data that you're producing, and the metadata that describes that data, and the metadata that is then also available for searching, so that you can find it. The accessible part is about the retrievability of the data. So if you have the identifier, how can you get to the data? That should be through protocols that are free and open. There's also in the FAIR principles this notion of authentication and authorization, because the FAIR principles are not necessarily only for open data. So also data that is for some reason cannot be shared. So maybe there's an embargo, maybe there are sort of security issues around it. Still, having that data follow these FAIR principles would be good. And in many cases, that data that might not be openly available might be openly available in the future. So that it would be good to follow the same principles. And an important part of the accessibility also is thinking about how you can actually know about data when it's been deleted, or when it's not relevant anymore, so that you still have the metadata that you can actually find out what the data was and what it was for. The interoperable part is very specific, also what Professor Daraio talked about, knowledge representation, ontologies, vocabularies, and linking, which is very important, of course, for the reuse of data, that you have links to other important information that needs to go together with the data. And then finally, the reusability part, where it is very important to have the right information that allows for reuse. So the provenance of the data, how it was created, and also the licensing of it. What can you do with the data? An important last part there on the reusability is also that the data and the metadata should be created using community standards, so that it's not something that you invent yourself, but that it's something that could be used throughout the community. So that in very short what the FAIR principles are about. But the question that we also had in the working group on the FAIR data maturity model is why do you want your data to be fair? And FAIR is something that aims at improving the reusability of research data. To facilitate the reuse of research data is the final goal of the FAIR principle. So fairness itself and the FAIR principles are not a means to an end. Sometimes people think about, oh, when I make my data fair, then it's okay. No, I think what is important to see that the FAIR principles are a means to an end. You do that to create the reusability of data. And also, many people who work in FAIR and the people who designed the FAIR principles don't see FAIR as a state, as an end state. It sees as a journey. You have data, you produce data, and then you need to go through a process of making the data fair so that it can be reused. Now, in the work that we did with the Research Data Alliance, we came up with a data maturity model that has several aspects. One aspect is that we have identified indicators. So this is more, let's say, actionable things that are meant by the FAIR principles. We did that by decomposing the descriptions of the FAIR principles into various sub criteria. We call them the indicators, and there is 41 of them in the data maturity model. I show here just a short list of the F and the A principles. We also did a specification of priorities of these indicators. So what are the things that are the most important? Where would you want to start if you were going to make your data fair? And then also a mechanism to measure the fairness in the way that on the radar charts that you see here, where you can actually say how far and how well you are doing on these various indicators, and it gives you an impression of where you could improve your fairness. That is something that we try to find a balance with the communities that we have. We had researchers, and we also had research funders, and we have a methodology that for both of those groups makes sense and they can use. There is a link just under the diagram here for the link to the data maturity model that was published last year in June by the Research Data Alliance. We have also said that the model is not a fixed document. It can be adapted. For example, you can have different community-specific requirements for the data, and you can adapt the model to reflect that. And also you can apply the model on various stages of the work. So you can do it before you actually start creating data in a data management plan, for example, that says how you're going to create data and how you're going to process it. But you can also do it after you have created the data to test how fair the data is and whether you have indeed satisfied the requirements that you set yourself at the beginning. So that is as sort of a summary of the work that we've done and the points that we have discussed with the working group at RDA is how do you do this? So first of all, we said, well, you need to consider at the beginning how fair you want your data to be. That means that you need to identify the data that you are going to create and that you want to be reusable. You'd like to define the scope of the potential reuse, because often people have a very clear idea of the reuse within their own community, but it's also important to think about whether there are other communities, other domains that might be close to your own domain, that you see a potential of reusing the data. And then based on that, you'd like to select a target level of fairness. So you want to select indicators and priorities from the fair data maturity model that makes sense for your particular use, and then specify the actions that you want to take. So that makes it actionable. And then important also that you have a way to evaluate through the life cycle of the data creation activities how you're developing your fairness of data. So this is sort of an idea, the ideas that we captured also from the discussions, and it is something that maybe there in the community here, the audience want to discuss in a little bit more detail. Thank you.
Yeah, thank you, Makx, for being fair to the time. I think we have an excellent panelist now. So now we would go to the discussant. We have three discussants as a part of this discussions, and what we do is that each discussant would raise one question. Please be brief. You can address to one of these, either another speakers who preceded you, or leave the question to one of them to pick up and answer it. And then we'll go one round, one after the other, and then hopefully we're managing well in the time, then we'll come back to the second and third, and we can be random in picking up the discussion. So let me request Dr. Murali Tarikare is an assistant professor at the Department of Library and Information Science at Central University of Himachal Pradesh, Dharmashala Murali, Dr. Murali.
Yeah. Hello, sir. My question is to Dr. Aastha. I just want to know, how the Web Observatory can help to create research communities in India, particularly with the library and information science professionals. Any lessons from your experience which you presented?
I think this is a question for me and Professor Shalini both, because we are aware of this initiative. So thank you for the question. And so I would like to start with this. In 2014, when I joined the Web Science Lab in IIITB, we were, so there was a Web Science Lab growing, and we knew that we do a lot of web science research. We were trying to understand how people, what is the celebrityness of, say, a person on Twitter, why you call somebody a celebrity, or what is the methodology behind the emotional contagion that goes around in our social media and other stuff. And then there was Professor Dame Wendy Hall in the Web Science Network in Southampton Uni, who was building this community across universities. So with the collaboration and with the British FCO helping us, we launched the Indian Web Observatory in. There is where the collaboration started, and we used to still call it as the triple ITB Web Observatory, which has now grown up to what we call as the Cogno Web Observatory, and IIT Madras is also a part of it. And Professor Sridhar from IIT Madras is part of it. We have an initiative which we call as the Guru Labs, which is a new way of teaching. And Professor Shalini, you are more in touch. I keep just with my on and off interactions with Srinath, I know about it. And but it's an active community. So if you search for Cogno Web Observatory, you will be able to see all the research projects and the data sets that they are putting, and you will be able to find the community of the PhD postdocs as well as the professors who are engaged with this initiative. And I would suggest they do quite an interesting stuff, and you should definitely join their network.
Yeah, may now ask Dr. Vasantaraju. He's at the government first grade college at Periyapatna.
Being a librarian, my question is very much centered on libraries. We did a small content analysis study to understand Indian research management landscape. We took IIT as a sample data candidate for our study. We found that no, except IIT Delhi library, no other libraries, other 22 IIT libraries are providing any kind of data management services. So in these observations, where do you situate the libraries in a larger data management, research data management framework? How Indian libraries should go about and address the research management issues or services?
Whom are we? Dr. Professor Cinzia, you would like to address this?
Yes, maybe I can say something. This is a very interesting question, because I think libraries have maybe the higher potential for being really actors for the research data management, but currently they are not so involved. So in my opinion, and this is also my personal opinion, also working for trying to support also my universities for what is connected to the evaluation, or to all the data connected aspects that relate also the connection of data. I think libraries can play really a much higher and much stronger role as the actor, because they have a lot of power because you have access to the bibliographic sources, to the databases, and there are also I can say people that can work and have skills to work on this. So I see really a lot of potential. Of course, there is some kind of, there is need, I think, of interaction and of interdisciplinary work in which librarians can collaborate with the computer scientists that develop the technologies to put together the different competencies, and also to help to support the governance of the universities, and then the governance of the higher education, or the policy interested people, to really exploit the research data management. But I think there is a need to share more these views, and also interesting conferences, workshops that put together different multidisciplinary competencies could be very important, because a lot of data that we have to produce for evaluation are also can be merged, can be supported by the infrastructure and the data that are currently available, but these kind of technologies can be expanded. So in my opinion, there is a lot of potentialities that can be really exploited on this. I don't know if I answered your question, but
Yes,
I think Dr.
thank you.
Björn wants to add something. You raised the hand. You want to add something? Yeah, please.
Yes, exactly. Because this is actually a very political question, isn't it? Because the role of libraries is, of course, central in a lot of ways if you expand your point of view beyond research data. Because what has been the role of libraries historically, traditionally? What have libraries done? They have taken the knowledge of the world that, you know, scientists have generated, researchers or scholars in general, and have archived it and made it available to the world. Now, we produce, as scientists, we produce now today, we produce a little bit more than just text. We produce data, we produce code. And so what could be more natural for libraries than to do the same thing that they have been doing for millennia, taking the products of scholars and preserving them, archiving them, curating them, and making them accessible to the world. Now, this is just different means, but before, these change of means of storage have happened as well. In the early days, it was scrolls, and then it was books. It was handwritten, it was printed. So things change, and also change technologically. So that didn't make the libraries go away all of a sudden just because the scrolls were changed into books and handwritten books were changed into printed books. Libraries stayed through these technological innovations. And this is why if you clicked on one of the three links that I provided, those are hosted, our data are hosted in the library. And the project that we have with this automated data deposition of the interlinked documents, this is also done in collaboration with our library. The Python script was written by the library and provided to us by the library that synchronizes our local workstations with the library publication server. And so I would argue that this is precisely what libraries should be spending their money on, and not just for data and code, but also for the texts as well. And so I've been arguing for years that the billions we spend on publishers are wasted. Libraries should stop paying these companies and should rather use that money to invest it into infrastructure that actually helps the general mission of scholarship, that is to create knowledge, archive it, curate it, and make it available to the world. And the money spent on publishers don't really do that.
Thank you for the perspective. I think, shall I now invite Anand Ramani? Oh, yeah, hold on.
Yeah. Thank you, sir, and greetings to all. My question is, how reliable and safe is to use the research data archived in research data management systems? Because if there are any errors in the data items stored in RDS systems, that could, lead to a serious, that could seriously affect the quality and findings of the future research works built on that, data. So using the data available in RDM systems to validate the results of a particular research work is okay, but conducting a fresh research using the research data collected by others is like, constructing your dream home on the foundation laid by, some unknown person. Even if you do the cost-benefit analysis of the RDM systems, they're not feasible for implementation in developing countries like India. So this could be one of the reasons why the experts in the past, paid no attention to the RDM system. So I would like to know what is your take on it. So do you agree with it or think in a different way?
Yes. Maybe I think it's a good question. It all comes down to basically the cost and the benefits of doing this. And what we've seen also in the discussions at the Research Data Alliance is that for individual researchers, there's only cost. There's no benefit. The benefit is in the wider world. So if you have the data and you bring it together, then there are other people that are going to have the benefit of that. What we can see is in Europe, at least the work that I've been doing also with the European Commission, is that the funders are actually forcing the researchers to think about that and put in the effort to provide the information to to the repositories, for example, in the right way so that it is available and it remains available. So it actually, there is sort of a forcing of the individual researchers by the money that they get, and they get a little bit more money to actually think about those things and to do those activities. And I think it's important that there is sort of this push and pull where researchers start to understand what the benefit is in the wider sense, and then see, we hope that that will help creating sort of a wider reuse of data.
Yeah, Professor Cinzia.
Yes, indeed, I think, of course, it's a matter of pushing, and the funders, as was said, try to push. Another way is to provide incentive. In fact, I've seen that now there are also some kind of databases that start to count citation to data. And there are also some publishers that publish research data papers. So if you want to share, of course, you do a lot of working on your data. And so for individual researchers, they can have an incentive in publishing and letting available their data, publishing a small papers that just introduce the data and you put the data attached. So this is another way of complementing the pushing with some incentives to let individuals to do this. I think this is starting to happen. But of course, we need to do a stronger policy, and the policy makers have a major role in this.
Yeah, again, Dr. Björn wants to contribute. Want to add something? Yes.
Yes, I'd like to add two aspects to this. That it does say something about our research system that we currently have, that you have to push researchers to do something that's in the interest of science, right? What does that mean if scientists don't do on their own volition what is good for science? That means we have some really perverse system going on right now. And I agree that at the moment, for most people, that's the case. But if this is, if sharing what we do with the world is what science is for, publicly funded science at least, then one might ask, why is there such a system where this is not done automatically? And this is the reason why we have constructed and designed the projects that we have. If data sharing is automatic, there's no cost. And if you then mitigate the issue of other people profiting from our data by not, for instance, by crediting the reuse of data, then you actually have a positive benefit. You have no cost because it's automatic, and you have the benefit that actually something that you are interested in, namely the science, why you collected the data, someone helps you with that. So for instance, if I publish my data automatically, that has happened, and someone looks at the data because they're also interested in it and they find a mistake, before you find it, you benefit from that directly. And so if you have no cost to sharing your data because it's automatically done anyway, this would be a direct benefit. And then if you're a student, as in our cases, in many of our cases, your data is automatically backed up. You don't have to worry about data backup because it's synchronized to the server automatically. So you don't have to do that in case something happens to your local machine. The same is true for me as a supervisor. The data are automatically deposited. I know where they are. If the student graduates and leaves, I don't have to chase them or force them to do anything because I have their data. Right? There's no forcing necessary because it's automated.
Okay, I think Dr. Aastha wants to add to the discussion.
Yeah, I will just, some of the very good points have already been listed. So just some additions from my side are that when we were doing this Web Observatory exercise and people were using the data that we collected in one part of the university, we had this challenge. So a solution that we did was that enriching the metadata that we were collecting with the data, associating with the data set. So we put something called as the attribution field, which was a mandatory field. So when you basically expose your data set. You need to tell where is that data coming from. And so apart from the licensing, that like the data source was made more explicit, and any changes of the derived data sets, then the granularity problem came in. Then how do you manage that kind of a problem? And just to say that not just the research data is bad at the governance of it, it's also like in the industry within the organization. And I can tell you very, very, both for the clients and my own organization, when we talk about managing the client data, managing the enterprise data, managing the data that we do the research R&D projects, and we develop new tools and products, we are not very good at managing that. And that's a whole new stream of data governance that's becoming more and more important. The finance community, some big organizations are addressing that, but that's mostly because of GDPR or compliance. But general best practices that we learn about provenance, about sharing from the research data is very, very transferable into the like the industrial community as well. And it's there is this, we are at this stage one, and there is a whole set of ladder that we need to step up the game. And also one more thing that we discovered during this publishing of the data sets and we using it for different purposes. So the BSI, the British Standard Institute, published a standard for metadata for IoT data sets. And when we started using it, the data sets complying with that standard, we started using for research, we discovered that there was a complete security threat because the security flag was not addressed in the metadata. So we had to go back to the BSI and make a whole new case and say that, okay, this is a problem and you need to verify your standard. So the standard was modified, and but it was a long route. It was good 8 months of continuous to and fro. So these changes are slow, but I think it will evolve with time. That's my point. Thank you.
Okay, thank you. We'll move to the next round of the questions. May I now invite Dr. Vasantarajan? You have a yeah, unmute yourself.
Yeah, my question is John Brembs, sir. The F1000 research journals that you have shown, it was excellent experiments. Is that the data journal is the new normal? Will it be becoming the future scholarly ecosystem? How do you see the developments of data journals?
So, I mean, personally, I cannot make predictions of the future. I can tell you how I personally would like to work. I would like to work in an environment where there are no journals, because journals themselves, their own top level, their only top level function is to sort scholarship into different areas, right? That's why you have a journal of neuroscience, a journal of archaeology, you have all these sorts of things. And as we know from all kinds of digital media, sorting things by journals by hand is not necessarily the most effective nor the most efficient way of sorting things. So what I would like to see is that every scholarly institution on this planet joins a scholarly infrastructure that takes care of both the narratives and the accompanying data and the code in an interactive way. And as an author, all I would like to do is I would write up my narrative. I would tell people what I've done, or what we've done. Usually it's a team effort. And then just hit publish and it'll be published. And any function that comes after that as an author, we can pick and choose as a community what we find valuable for our community, whether we peer review it or not, whether we want to collect certain data about reuse or not. All of these things come afterwards. And as a reader, what I would want is I would want to have a system, and this is easy to build these days. I want to have a system that greets me every morning and says, hey, look, here's these things that are interesting to you. And I'm in control whether I want to be these things directly at the top, because and whether they're peer reviewed or not is not relevant to me. If I'm a peer, I don't need another peer to read it for me. And then maybe things that are close to my field of research, but not so close that I understand the technical details. Maybe those I want to wait until I get them on my screen and presented to me until they have been peer reviewed, so that I know, okay, some people who have more understanding of the technical details of the experiments than me have looked at it, and this is fine. And so then I will see it so that I'm in control of what is relevant to me, and not some human editor at some journal who thinks this may potentially be interesting to their readers. And so, and as an evaluator, those are the three main roles that I have as a scholar in such a system. As an evaluator, I want to, let's say, a peer reviewer, I want to comment directly on the manuscript. You know, if I'm there, I want to put comments there. I want to have a system where I can put comments there and interact with the authors as if I would be an author. I would make suggestions here, suggestions there. And then the authors, in the cases where it's simple and trivial, they could just hit accept, 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 and their manuscript is improved without them putting extra work into, okay, line 555, replace the comma with a semicolon, and these sorts of things like we do it now. This is absurd. This is like 20 years ago, 30 years ago. And so this is what I would want things to be. Now, if you ask me, are things going to be like that? If I look back the last 30 years, I'm skeptical.
Yes. Okay, thank you. Shall we ask, can I ask Dr. Murali to add? Dr. Murali?
If I'm audible again.
Yeah.
My second question is again to Aastha only, Dr. Aastha. Like, how would data sharing and infrastructure support policy formation and business?
Okay, thank you for the question. I will try to answer it using an example. So recently, one of the city councils in which we work with asked us that they have been trying to digitize their city to make it a smart city. So they are having a lot of data that they are gathering, but they don't know how to maintain it. So their first question to us was, we want to create a data catalog. We want to be able to share this data with the people that live in the city, and we want like the university in the city to be able to access the data so that they can research for us. Basically, it's a win-win situation. They want to create this ecosystem where the university can access the city data, the businesses can use the apps that are being developed by the citizens or something. Everyone should be talking the language of the data. And the first thing was that we have researched on the internet, and it seems like CCAN is an amazing data repository standard that we should be using. And can you help us with the different challenges that might come through this? And so this is just one of the challenges that the City Council came with. And our response to them was exactly what we did for the Web Observatory or the IoT Observatory, that, okay, you can have a catalog of the data, but who is going to maintain? Because usually you have these catalogs, but nobody updates them. So how do you create that community where you would be updating this data, or how would you be maintaining this data, and what will be the protocol for sharing? Because if you see in a city, when data sharing, so in the research communities, we are all very proactive and we want to share. But when it comes to businesses, everyone wants to monetize the data that they own. So a supermarket having, say, 100 parking slots, and you want to make it into a COVID testing center, and they would want to charge the city council for that. So that kind of dynamics are very contrasting. So I think monetization was one new factor that we had to cater, but the technical challenges were the same. So it becomes like a policy plus technical challenge for us, which was very, very interesting. I don't have a clear answer what is a win-win strategy, but I can tell you that this was a challenge that came across. So yeah.
Thank you, Dr. Aastha. Dr. Anand, you.
Yes, sir. My second question is also open to all the panelists. Anybody can respond to that. A majority of the academic and research institutions in the developing countries like India are not really equipped with the necessary infrastructure facilities to handle the complexities involved in the RDM process. So in this case, if such institutions who are not capable of handling the complexities involved in RDM wish to go for a kind of cloud storage facility offered by some private players in future. So what could be the implications of that, so in terms of data security, accessibility, and long-term preservation? Whether such plans are really advisable? Because the institutions they handle with a kind of sensitive data. So if we give their data to the private players, whether it is going to be safe or how?
Yeah, I think let me introduce Professor Cinzia.
Yes, I think that an investment in a research data infrastructure would be exactly useful for developing countries. And I think it would be useful also for European countries, but also especially for developing countries, because you can start investing on a smaller infrastructure, and then you can increasingly extend it and consolidate it. But I think that, I mean, if you do not invest, you can have the two different possibilities. As I showed in one of my slides, you have the silos approach. When you need some data for some purposes, you put together the data, you spend money to integrate the data to solve one problem. And then each time you have to change your question, you should invest again in finding the data, putting together a lot of efforts of integration. You use the data, and a few days later you have another question, and so you have to start again in finding the different data, a lot of effort to integrate just to answer these questions. But in the meantime, policymakers need another question, have another question. And so I think really that thinking in a kind of medium long term infrastructure and investment is something that can pay off. It's a kind of an option you have. You spend small each year, but you have to rebuild again and a lot of efforts, or you decide to invest in an infrastructure. And I think this is a policy question. You should really invest to boost also and to increase and to have some kind of efforts in terms of developments. My opinion is that, and this is something that does not apply only to India, but also to Europe. Also, Europe, I think, should really invest in building research infrastructures, because this pays. It's an investment that pays. We pay, but we know that we can, up a few years, we have the return of the investment. It's a kind of options, theory of options, in which you have the option of investing instead of spending the money. This is my view.
I think, Dr. Anand, we need to really think about the private cloud services, government. I think these distinctions would go. I think the major cloud players are not governments now. I think so. I think this fear is going to be there in the beginning, but I think it would go away. I think we should not worry about it. As I think tomorrow, I think everybody should be on the same platform. I think so. I guess that let the infrastructure grow, let the investment be made, then we'll think about whether it's private or public. I guess that I think we need to start thinking a little differently. The whole world is going to be one. Yeah, I think Dr. Makx, you want to add anything on this question about the infrastructure?
Well, I fully support Dr. Daraio's, Professor Daraio's view. There is an investment to be made, and that is, I really believe that it's up to governments to make sure that money that is available for research is well spent. And well spent to me means that there is a way that infrastructures are built that researchers can use. What I liked also about the comment that Professor Daraio made is that if you do not invest there, and if there is public sector organizations and ministries that invest, if they do not provide the money for those kind of infrastructures, they're actually killing their investments on research. And I think they should be aware of that, and they should actually do that. And this happens in Europe. In Europe, there is quite a lot of work and funding that has been provided by the European Commission. There is the European Open Science Cloud, which has been developed. There are various research infrastructures being developed. that now all come together and connect. And I think this is really a crucial point for everybody in the world, not just in developing countries, but also in completely around the world in a wider context.
Okay, I think Dr. Bond want to add something. Yes.
Yes, a short comment on what was just said about additional investment monies. I tried to allude to that in a previous comment already. The nice thing about this particular investment is that the money, at least in the Western style countries, and I'm not familiar with low and middle income countries, but in the Western countries, at least, Western style, high income countries, the money is already there. So especially when you mention the European Open Science Cloud, it's a gigantic, in my opinion, a gigantic waste of money, because it would have been much more sensible to use the money that we're currently spending on a counterproductive journal system, to use that money, which is multiples of what, for instance, the European Open Science Cloud costs, to invest that kind of money rather than in a journal structure that hurts science into an infrastructure that actually supports science. So what Europe is doing right now with, for instance, the European Open Science Cloud, is that it keeps up on the one hand, it keeps up the system that is bad for science, and then with its own money, and then spends additional money on a system that is conceptually counteracting the first system that they're also paying. So right now, it seems as if rich countries have so much money that they pay on both ends, both on things that are bad for science and on things that are good for science. And if you ever needed any evidence that Europe has more money than it's good for itself, than is actually good for science, then you just need to look at these sorts of things. This is, I cannot begin to describe the absurdity of this situation.
Thank you. I think there are some hands raised from the audience. We'll move to the audience Q&A now.
We can take questions which are there in Q&A box. How to handle challenges related to data decay or digital decay, like data degradation, data obsolescence, and data breakdown?
Yes, if I may answer to this question, before answering to this question, just a small comments on the previous discussion we had. I think that one advantage for developing countries is that you can start from scratch and design your own research infrastructure well, instead of conflicting what we have done, too much money. I think you can really start from scratch and do sensitive investment that can be incremented I would say in a clever way. Coming back to the question, the challenge can be solved, of course, if you have an infrastructure like an ontology-based infrastructure. The idea is that you do not have to rely. I mean, it's less important the data that becomes obsolete, because you have your conceptual framework, your conceptual description of the data. And so when you can link the same concept to this data set, or as soon as you have a new data set or an updated version of the data set, you can just add, and you have a new here, or you have an integrated version. So once you have settled the system, it's very easy to take into account these the updates of the system. Of course, you need a structure that should manage this. But from the conceptual point of view, it's easier than starting each time from scratch without having the conceptual organization of the data.
Yeah, the question is how to create awareness among the researchers about importance of research data management, newest skills, insight concerning data management.
Yes, if I may answer to this, I mean, if you are an applied researcher, this is also from a kind of economic point of view convenient, because I've seen, for instance, how much work and how it is demanding to collect data, cleaning the data, work on the data before having the possibility to use the data. And if you want to change your research questions, if you have to start again from the beginning, this could be really frustrating. So I think it is it is convenient to have a data management system, a research data management system that allows you to answer to different questions or to exploit the data in different ways than just one. This is the advantage. Of course, the cost is you have to have the infrastructure and you have to know how to use it. But we are learning, as also applied researchers are learning that the data are really important for their research. And so they need an infrastructure to exploit the available information and the available knowledge. To extract knowledge from the data, it's important to learn these skills. But of course, we need also more initiatives, seminars, also within universities to introduce to researchers that use data why they benefit from having access to these research infrastructures, what they can gain for their work, for their research. This is an important activity of communication and dissemination that I think should be done.
I think, Devendra, let's try out these people who raised hands. Rajaraj Cholan is not there. Maybe Ramesha?
Sir, good evening, sir.
Good evening.
Good evening. We can hear you. Yeah,
okay.
Please.
I have one major research project which was funded by Indian Council for Social Science Research. The topic is to create a social science research data repository. Now, I have taken some theses from the social science research, which was submitted to different universities in India. We have picked up some tables, graphs, and images, and we have started building the research data repository. What are the IPR or copyright issues is involved in building this social science research data repository?
Oh, Professor Cinzia. Yes, okay. I think, yeah, please.
If I just can, I mean, I think that in social science, it is the ideal also field in which you can exploit the ontology modeling. But for ontology, I would say also not only in terms, first of all, you can develop your ontology for modeling the different quantities. And there are several open available open software to model your ontologies, to create your ontologies, to represent the main concepts that are in your database. There is one that is Protégé, and there is also Heddy, that is another ontology that is open. You can download it and you can model the different concepts. So you can start by using these tools that are available for your for modeling the different repositories that you have. If you want, I can send you some links where to download it. If you could send an email or
okay. Sure.
Yeah, Mr. Makx, you want to add something to the answer?
Yes, yeah. I just wanted to raise an issue there with some of the discussions that we're having, and I think the word standardization for me is important. The way that everybody would try to use, for example, ontologies that are already there rather than inventing their own. And I think especially for the interoperability and for the reuse, it is really important that people think about finding the right standards for their work rather than investing in building new things that other people do not understand. So I wanted to just make sure that people understand or people realize that standardization is a really important word in this context.
Yeah, I think, shall we ask Chudamani Subbaraya?
Instead of each country trying to build its repository, this complete projection can be taken by the UNESCO or some other science agency with the United Nations panel, so that it is all consolidated and organized.
Yeah, it's a good suggestion, but I think
Can be a
Yes,
part of the wish list.
it's a good suggestion, but I think maybe UNESCO may not be the right agency, but it's a good suggestion. But I think, when we bringing people together is a challenge, but it's a good suggestion. Yeah.
Yeah, I think Makx.
Max, want to add? Okay, yeah, Max.
Yeah,
Yeah.
yes. I wanted to really push and the Research Data Alliance, because that is a group that is not an official organization like the United Nations, but it's certainly a place where people are welcome to come and to discuss their issues. There are a wide range of working groups in the Research Data Alliance, and I would really encourage people to look at that organization as a platform where you can share ideas and also find out about what other people are doing.
MS Sridhar has asked this question. What are challenges of non-numeric qualitative social research data in RDM?
First question for the challenges of non-numeric, I think
Yes.
it's important, in my view at least, to think about the representation and the model of the reality. Because if we don't have a model, or if we don't have an understanding of what happens, it's very difficult to exploit data, but also to include non-numeric or qualitative information. It is important to take into account the contextualization, but this is why we really need to have a model of the reality or of the domain of interest. And I can assure, because we really tried it by developing Sapienza, the ontology of the multidimensional research assessment, we were able to really think about what we are modeling, the different concepts, what is a publication. And also thinking about this, you can have a better understanding of your domain. This is really important. We model, just to tell you, in our ontology, a publication is just a way to let publicly available. Then you have the content of the publication. And then you have, they are not exactly the same. You can have a good content that is just in a piece of paper in your office, and then you can have the same content that is published many times because you want to increase your bibliometric indicators. And so, I mean, if you think about your content, the context of your, you to think about what you are modeling, the reality, it's a way also to include these non-quantitative aspects, and you can do it within an ontology. Then it is different to find the data. But at least from a conceptual point of view, if you have done a good model, you know what you are not able to measure. And this is important, because if you model only what you have in your data, you have a very narrow view of the reality. If you use an ontology, you say, okay, there is quality. What it is quality? Do we have all the proxies of qualities? It's really difficult. We have this, we provide some proxies, but we know what we are not able to measure. And this is very important, I think, also for the interpretation of the quantitative measure or data that we have. I don't know if I answered the question.
I think, thank you. I think we have one question left in the Q&A. I think Balbharati Srinivasan asked a very interesting question. These doubts will come. What would happen if the mishandling or deleting of the data? Obviously, there must be backup mechanisms, and I think it's open to the author, but anybody wants to add? I mean, have you experienced data being mishandled by somebody else? We are always worried whether somebody else will hack in and things like that. I think, is it an issue yet, or any of you, especially somebody is handling the data repository?
I can try to answer that one. So that was a basic concern when we started publishing the data sets on the Web Observatory. So the first two things that we did was about the access rights. So and also the second thing was that if somebody was basically, it's just like the GitHub works, right? So you check out the code, but then once you are putting it back, then it is like a derived data set. It is linked to the original data set, but it is no more the same data set. And you also, for some data sets, like which were not open data sets, it was mandatory to sign in into the system. So you know that what are the credentials of the person accessing the system. It happens. We did it accidentally to each other's data sets, forget about anyone else accessing it. So there are all sorts. This is a very, very normal data set. But then at the end of the day, as the whole stream of ethics and data ethics comes into the picture of the use and reuse of the data, which I think will go just too out of the scope for today.
No, when you create infrastructure, the infrastructure to protect also part of infrastructure.
Yes, exactly. It is like it's just like developing a software, right? So I draw this notion, which I was very interesting from a discussion within our research lab, and everyone said that the way Wikipedia developed, the idea for Wikipedia was just to have an online encyclopedia, but the way it has created the whole community of MediaWiki and the Wikipedians and an active community around it. So that's like the way the platform, the technological platform remains this much, but the social impact becomes bigger. So it's the same with the data sharing as well.
Yeah, that the fear is genuine, but I think there will be solutions. Yeah, thank you. I think
hello, I have a question. I have a question again to Cinzia, Professor Cinzia, madam. Data practices, now especially in social science and humanities, occurs in a very different context. So lack of standardization is a big issue. You did mention in your presentation that how especially in India, researchers are not, because of lack of standardization, are not, depositing their data, are coming forward. How do you address these issues, especially in Indian context? Can you show some light on that?
Yes, this is really an interesting question. Maybe not so easy to answer. One way, I don't know if I can answer, but one way would be to use the model of the context. In fact, in our ontology, we had a module that is I don't know, maybe it's not good to come back, but one of the module is exactly representations, and we use these just for instance because we wanted to include the representation of the different contexts if we use different databases. For instance, for the publications, you can use Web of Science, you can use Scopus, you can use publicly available repositories. For instance, we consider the database of computer scientists that is openly available. So according to the source, you have a different representations. What you ask is a bit more complex because it requires to have different models of different contexts. And of course, this is more demanding because you should model the different concepts. If you have the context one, then another model. So if you have the context two, another model if you have. And so this, of course, requires more time to model the different realities. But once you have done this, you can learn a lot because you have the conceptual analysis, and the powerful of these technologies is that you can link the available data to these conceptual representations. You can see immediately that for some of the concepts you don't have the data, but this is not a problem because you say, okay, if I want to invest, if I want to start a new project, I can see where I need to invest, what kind of variables, what kind of information I need to have. And so this is a kind of a way also to thinking as data as an infrastructure that gives you some powerful to think about what you don't have and what you would like to have. And it is important also to have the modeling exercise done by interdisciplinary people with different background, with different views, that knows also different methods. This is really, I think, a very interesting work, but requires time, effort, project, and of course, money. This should be really, I think, supported. But I think it is really something on which to invest.
Thank you. There are two questions in the one by Putraj Chaukumit. I think his suggestion was, why not InfibNet? Why not NIC? Yes, these are all suggestions which we can consider. I think we need to.
Dr. Shalini want to ask one question, I guess.
Yeah. Shalini will be the last question to ask. I think we are doing well on time. I want to end in time also. I want to hand over to Shalini. Yes, Dr. Shalini, your question, please.
Yeah, my question is to Dr. Brembs. John, you are very passionate about transforming or revolutionizing the science norms themselves, not just the paradigm or the scholarly communication. I like it. I am also for it. Only question I have, or rather I have two questions, okay? One is, if I have understood you correctly, you said, why go with this journal, article, etc. So you want to sort of, unbundle the journal and the journal article. You have a huge scientific research infrastructure wherein each researcher or author, puts in his or her own thing, right? Is that what you meant? Okay. Next, if
Yeah, that's what I meant.
Sorry?
Because right. I mean, do you see journals in Facebook? Do you see journals in Twitter? They do just fine. They channel information just fine. They don't need journals. There's a reason why new media don't reinvent journals. There's a good reason for it.
Yeah, I like that idea, but my question is, that's what kind of a model you have in your vision? Is it like the Wikipedia model or the Facebook? Because each of these social media, or what we call as the crowdsourced platforms, have a slightly different model, right? What is your model? That was one question. I'll also ask the second question. The second question is, like, if it is like a Facebook, you did mention that, you would like to comment directly on the research of your researchers. But we have seen in the case of, say, Facebook or any of these online media, the trolls business, right? See, you are a serious researcher, you are interested in research and advancing science, and you have integrity, etc. But there are this bunch of others who come and comment on it. And then that disrupts the whole thing, right? There is a flip side to that. We have all seen it and experienced it.
I think before Dr. Brembs, Shalini, whenever we try new things, there would be problems. I think we need to.
No, I want his vision on that, because he envisioned that, right?
Yeah. No, let me add my part of it. I think we need to find solutions. I think new problem, new media, new thing. Yeah, Dr. Brembs, you can add that. Let me add my thing later. Yeah, you please.
So it's fine. My daughter is 10 and she's just learned the golden rule of the internet. Don't read the comments.
Okay.
Yeah, but I think to me, Dr. Shalini, we have a long way to go. Today, we don't even know what comments were made by the reviewers. This is not known to us. Now, from that end to somebody commenting on our work, this is the other extreme we are going. I think it's a long way to go, but let's not prevent it.
Why I brought it up is, in my view, Wikipedia model is a better one, wherein there is this community crowdsourced one, but there is some kind of a, I would say, editorializing that is happening.
Yeah, but I think
in general, I would say it is a fairly good model. I mean, it has its own, and then you also see all the other thing good about Wikipedia media wiki is that you can see all the versions. Even if someone has deleted, well, I can go back to that and see.
Yes.
So it is not gone forever, but at least in the face of it, you see that there is some editorializing. So in my view,
I think
Wikipedia is a good model. So no, I want to listen to Dr. Brembs' view on that, because it was he who envisioned that, right?
Yeah. You don't want to listen to my views, I guess. That maybe we can talk privately. Yeah. Okay, Dr. Brembs, yes.
So indeed, Wikipedia is a superior system, but I don't think you can adopt it one-to-one to the scholarly system. I think it would, the reasons for that would go too far. But I think I'd approach this argument from a different direction. There are reasons why we examine our students. There are reasons why they have to pass degrees. There are reasons why in the real world we run around with IDs on us in most places, or at least if we don't have an official ID, we have some other documentation that documents who we are. And pretty much analogous reasons, and in the case of examinations and titles, those are the reasons. You would have a scholarly system where you would also accumulate certain standing. And this has been known for, I don't know, more than 20 years. I think the first term people developed for this was karma, which is interesting because it's an Indian concept, right? But I'm not, of course, not referring to the Indian concept of karma, but to the technological concept of kudos or whatever you want to call it, right? And what you would say is academic standing would be an English translation of it. And if you enroll as a student, you have passed a certain undergraduate, a certain school degree to be allowed to university. And if you make your bachelor's degree, you have passed an exam to make it into your master's degree in those countries where you have that. And if you have a master's in those places that require it, you're allowed to apply for a PhD and so on. So you have to constantly, in science and in scholarship in general, you have to constantly prove your competence and your expertise. People don't take your expertise for granted. And I see no reason why this system that has served, I would argue, if I wouldn't find this system useful, I would stop writing exams for my students and grading them, right? I still think this is useful, and I would use that. And I think if you build on top of that a system where even if you're an old gray-haired guy like me, you can still increase or decrease your standing depending on how smart or stupid your comments are, then I think the need for actual human interference and moderation will not be zero, but will be decreased and mitigated simply because of the self-interest of everyone involved.
Dr. Anand has one small question, sir.
Yeah, so one last question. I mean, I would like to point out that if you look at the scholarly communication, there are two things which are really miserably not addressed. So one is rights. If you look at funding agencies, if you look at organizations, and if you look at the authors, none of them are really bothered about the funding, the money they spend, and the rights. None of them own the rights. In fact, they don't bother about the rights and also retaining the rights. At the same time, the second flaw in the whole scholarly communication is the monetization or the incentivization. In fact, that is also not at all there. But if you look at carefully, publishing industry has always oversmarted the so-called scholars and the rights issue, and also bringing in the incentivization or the monetization. There is no solution for this. And as Professor Shalini said, we need really definitely alternative models, some Wikipedia, wherein it will bring in something revolutionary or something very different. So I just wanted to ask one or two comments from the panelists.
We are running out of time, Dr. Anand, and I think,
okay.
Yeah, I think today, I just want to add my comment to Wikipedia. Today, Wikipedia is what it is because there's no credit to the articles that are written on Wikipedia. The moment you give credit to that article, the moment you start imposing editorial process, we will get back to the typical system. But this debate can go on offline. I want to end on time because all the participants have been extremely cooperative with me. They were just sticking to the time. I also want to stick to the time. I think you all agree that we had excellent discussions. I think for Cinzia, I really touched two things which are very important to me. One is I think social cohesion, which is important. And also you raised the question about data quality. I think this is how you need to pay attention as more and more data becomes available and more people start using them. Then these becomes very important. And I think it's a very important point to me, which you raised. In addition to all the question answers were raising to what about infrastructure, what will happen to private cloud players. I think all these questions will come when things are new. I guess I think the questions raised by panelists, I think the new models, what Dr. Brembs said about it, Makx talked about being fair. One of the most difficult things in life is to be fair. I think we have to struggle to be fair. I guess that's the challenge of being fair. I think Makx mentioned about it. I think, and then I think Dr. Aastha talked about her experience. She was around in Bangalore, and then she started that the repository, and it's growing. And all I can see that all the questions asked were the curiosity to see what would happen if the data becomes available, what will happen if somebody handles it. I think these are all expected lines of fears when new technology comes. I think every new technology, when it comes, these questions would come. And I think it's important to raise these questions so that when you are constructing the infrastructure or providing the infrastructure, these things also can be taken into consideration. I think that is where I think all of us have to flag these issues. Don't only flag the advantage of it, but I think we should also flag the precautions we have to take. One is to make the infrastructure available, other is to ensure that. But I also want to say, I also foresee, I don't know, in the beginning I mentioned to you, today we're talking about data repositories for web resources, Twitter data, but I think we are ignoring large amount of experimental data that is generated in the laboratories. I think we need to address them. I think those, let us say I take a microstructure and that should be made available for somebody to interpret it, and somebody does an experiment in a biological laboratories. I think we need to, I think right now the concentration is on the large data or astronomical data, or these are all very exciting, but in a large amount of possibilities are available. I do an experiment in my lab. I think others need not repeat that experiment. I think it would bring lot of homogenization. I think, you know, the poor countries or the rich countries, infrastructure. I think I see great opportunities when this data becomes available. I think so. Your experimental data, making it available for people to interpret. I think you all agree with me. We had a wonderful session. I want to particularly thank all the speakers for making my life very easy. In fact, I've been very particular that whenever you start a session, timekeeping is very important. You hardly gave me any job, though Dr. Shalini warned you that I will stop, but you didn't give me that opportunity. Thank you all for a very interesting active participation, and then also for all the audience who have been actively participated, a lot of questions. I thank you all.
It is unplanned, a sudden one. I just want to make a small announcement about tomorrow's program. Tomorrow there are 3 sessions. Session number 1 starting at 10:30 and 10:30 to 1 p.m. Session number 2 starting at 3 p.m. That is 3 p.m. to 5:30 p.m. like it was the previous 2 days and today. And there is one more last session, session number 3 tomorrow, that starts at 6 o'clock and ends at 7:15. That is a special session. It is a session on case studies in innovation, and it is connected with the Informatics Innovation Award. The LTC 2021 set up a team of juries, and we received several nominations, and these nominations were reviewed, and out of some 30 and odd innovations received from various institutions, 5 are selected for presentation in tomorrow's session in case studies in innovation. These 5 presentations will be finally judged by the jury, and also there will be audience vote for that. Based on the jury's final assessment and audience vote, we will be selecting, jury will be selecting 2 best presentations for the award, Informatics Innovation Award. I welcome all of you to join that session, and also that will be followed by valedictory address by Dr. Rajshekaran Pillai, who are the former Vice Chancellor of, former Chairman of UGC, and currently Vice Chancellor of Somaiya Vidya Vihar University in Bombay. Thank you all.
Thank you all. Thanks for your time, commitment, and your efforts, and of course your enthusiasm to participate in this. So it's been wonderful having you all. So till we see next time, for the participants tomorrow, all the participants tomorrow, and to our panelists and speakers also, if you can join us for the rest of the sessions tomorrow, it would be wonderful. Thank you.